Hello, everyone. In this lesson, please follow me to apply Profinet communication methods to achieve data exchange between robots, touchscreens, and PLCs, completing our practical tasks. This lesson mainly covers the following content. To achieve Profinet Ethernet communication between industrial robots and PLCs, corresponding software and hardware conditions must be met. The software condition is that the robot manufacturer loads drivers supporting the Profinet communication protocol and menu options in the system at the time of factory shipment. The hardware condition is that the industrial robot side is equipped with a PROFIBUS communication card, which is connected to the PLC via an Ethernet cable. After meeting the software and hardware conditions for Profinet communication, we still need to perform some configurations in the TI portal software to achieve communication between the robot and the PLC. The specific steps are: 1. Hardware configuration of the S7-1200 series PLC. 2. Installation of the GSD file. 3. Configuration of the FANUC robot controller module. These steps have been explained in detail in previous lessons. In this lesson, I will lead you through a review of the configuration of the FANUC robot controller 1.0 module. First, we need to add the robot to the project. After installing the GSD file, in the TI portal hardware catalog, select Other Field Devices, Profinet I/O, FANUC in sequence. Double-click on the FANUC robot controller module to add it. View the robot module in the network view and click to enter device view for networking. Double-click the robot's Ethernet port, and in the pop-up Ethernet address options below, we need to add a new subnet, set the robot's IP address, and Profinet device name. After setting this up, go back to the device and network view, click on the unassigned text in the robot block, and from the pop-up menu, select the PLC_1 Profinet interface option. You will then see that the PLC and robot are connected together. Next, in device view, under catalog, modules, double-click to add an 8 input bytes module and an 8 output bytes module. This example uses 8 bytes each, but you can choose as needed. Set the robot I/O starting address to 121. Upon completion, the I/O addresses will be displayed in the variable options below. After setting the PLC address, click Menu, I/O, Profinet in the FANUC robot's teach pendant to make settings. Set channel 1 to invalid and channel 2 to valid. Assign the IP address, ensuring consistency with the IP and device name in the TI portal software. Next, move the cursor to I/O device. Press the disk key on the teach pendant to switch to the right-hand screen and set the slots. The slot settings must match the number of communication bytes we previously added, so both DI and DO should be set to 8 bytes. Our communication case requires the following functionality. When pressing the Command A button on the touchscreen, the robot moves to point P to pick up the goods and transports them to location A. After a 2-second pause, it sends Command B to the PLC and returns to the home point. While the Command A complete indicator light on the touchscreen turns on. When pressing the Command C button on the touchscreen, the robot moves to point P to pick up the goods and transports them to location C. After a 2-second pause, it sends Command D to the PLC and returns to the home point. While the Command C complete indicator light on the touchscreen turns on. From analysis, we know that after picking up the goods, the robot's actions will branch into 2 paths, moving to location A and location C. Therefore, at least 2 digital input signals need to be configured to receive commands from the PLC. Similarly, after completing the transportation, 2 digital output signals need to be configured to convey information to the PLC. After setting this up, restart the robot to make the settings effective. Once the I/O configuration is complete, let's write the robot program. Run the main program and call different subroutines through conditional comparison instructions if the 2 subroutines execute commands A and C issued by the PLC, respectively, picking up cubes and transporting them to different locations. Upon completion, They provide feedback to the PLC and return to the home point. In this lesson, we will also connect the touchscreen device to the PLC, so we need to write a new PLC program. Program segment 1 is used to issue command A to the robot. Program segment 2 is used to issue command C to the robot. Program segment 3 shows the completion of executing command A. Program segment 4 shows the completion of executing command C. How does the Siemens HMI touch panel establish a connection with the PLC? Let's learn it now. The method for the Siemens HMI touch panel to establish a connection with the PLC is as follows. Under the project tree in the TI Portal software, select Add New Device, choose HMI, find the model specification you want to use, check Start Device Wizard, and click OK to enter the wizard. Click Browse, select the PLC, and confirm to establish the connection. After establishing the connection, based on the already written PLC program, we create corresponding buttons and indicator lights in the HMI editing interface to send commands to the robot and display return signals. Here is the HMI panel after configuration. 1. At this moment, pressing the Command A button on the touchscreen turns the Command A indicator light gray. 2. Running the robot's main program, we can see the robot moving from the home point to point P, picking up the block and transporting it to point A, releasing the gripper to drop the block, waiting for 2 seconds, and then returning to the home point. 3. At the same time, the robot sends feedback signal B to the PLC, and the Command A complete indicator light turns gray. 4. Pressing the Reset button on the touchscreen turns all indicator lights gray, resetting the command. 5. Press the Command C button on the touchscreen. 6. Then run the robot's main program. We can see the robot moving from the home point to point P, picking up the block and transporting it to point C, releasing the gripper to drop the block, waiting for 2 seconds, and then returning to the home point. At the same time, the robot sends feedback signal D to the PLC, and the Command C complete indicator light turns gray. With this, our project function demonstration is complete. We have achieved data interaction between the PLC, HMI, and industrial robot under Profinet communication mode. In the linkage process between industrial robots and production equipment, cooperation and coordination are crucial. In fact, not only do machines need to coordinate and cooperate with each other, but so do multiple departments and members. You should also experience the role of communication and listening in your future studies and work, respecting each other's opinions. Lastly, please complete the following exercises. Thank you all for your learning and watching. See you in the next lesson.